I'm 3 minutes late to the contest. I thought it's at 2:45, but it's at 2:35. Feb 8. With a fence consisting of n birds, each 1 meter wide, and to the left and the right of the exit are fences of other plots. Some of the birds of the fence want to be removed for the construction of a bathhouse. Possibly all or none, while there is an automatic lawn mower on the plot with W meters wide, that is, must not leave the plot through a hole in fence. So we'll try to do the greedy one. We will do W minus, not W, yeah, we will do W minus 1 and then 1. W minus 1 and then 1. So what's the answer? You can remove W minus 1 and then 1. W minus 1 and then 1. W minus 1 and then 1. So this goes until so from one side we are doing greedy, so that's fine. That should be good enough. We can always claim that. Okay, so it's W minus 1 and then 1 fence. So you can remove W minus 1 fences and so on. Okay, so we are trying to take remainder with W. If it is divisible by W, so it is floor of W minus. So I think it is W minus 1 times N by W. If it is divisible, we have to use the last one too. So if it is not divisible, then we have W minus 1 things here. So we need not use that. So it's floor into that. Int N W seen N W answer equals to W minus 1 times N by W see out answer. Oh, it's failing. Sorry, how many you can remove, right? So I think it's N minus N by W. So this is right. How many you cannot remove? I mean, I haven't counted the last few things. Now I have counted the last few things too. Mark loves money very much and he keeps most of it in the bank. He stores his money in N different banks. In the eighth bank, he has AI rubles. One day, Mark decided to gather all his money in one bank, so he will be transferring money from one bank account to another. All interbank transfers are arranged in the same way. He can transfer only X rubles in one transfer and considering all fees. Y rubles will be credited to the account. Since banks want to make a profit, Y less is not equals to X. Is it possible that Mark will not be able to transfer all his money to one bank, but he wants to find the maximum number of rubles that can end up in any bank? So he may not transfer everything, right? Sometimes not transferring everything, leaving something alone might be better. Okay, sometimes because if everything is huge and if you're trying to move everything to one bank, y is greater than or equals to 1. So I think if some bank is there, always moving things to there would be better, right? So there is an optimal bank for sure. And okay, there is an optimal bank for sure. If you have fixed the optimal bank, let's say, okay, let that optimal bank had jet plus, let's say there is something else, outside one or like remaining one. How many times, how much money you can get greedily from outside to here? Just think about that, and then we can brute force this shit. How much money you can get from outside to here? You will do, you can only do x, right? So how many x's you can do? It's like r by x. Okay, this is the amount you can do times y. So this is just the amount. So you brute force this. So this will be the summation for everything, but for one thing it will be this instead of that. Okay, so we are brute forcing. We can brute force this easily. Int n x y c in x y and int total equals to 0. Okay, total r, tot r plus equals to a of I by x times y. If all of them are going to one bank, this would be the optimal one, right? Int I equals to 0, int answer equals to, let's say, 0, which is never possible, and then we'll do answer of max. Now we are trying to brute force z value z. Okay, so to brute force z, what do we do? Answer equals to max of answer comma tot r minus of ai by x times y plus ai. I'm not thinking, I'm just brute forcing this because it's possible to brute force. I mean, I'm not thinking further, is what I mean. So that passed. Also, this passed. So let's go to C. Uh, Bob, the genius spy, has intercepted an encrypted message. He assumes that it contains a secret information and is actively engaged in deciphering it. The note, which has fallen into the hands of the spy, consists of case strips, each of length n and containing strict lowercase letters. With extensive experience in deciphering such documents, Bob gets that the message he is interested in is also a string of length n. So we have each of length n, we have case strips, and the message we want to decipher is also of length n, and the ith letter of this message corresponds to the ith letter of one of the strips. Okay, so we have k strips, and ith letter will be ith letter among one of these. Even that is fixed. So we have this ith letter, k strips are there, like ith letter will be like one of them. Okay. According to Bob, the informativity of a string S is defined as the minimum positive integer d such that the string t of length d exists, and S can be transformed by repeating t several times. So, what does this mean? The informativity of a string S is defined as the minimum positive integer d such that string t of length d exists and S can be formed by repeating t several times. Means d must divide n, and informativity of S can be defined as minimum positive integer d such that, yeah. So if informativity is low, that is good. So it's like repetition, like what length can repeat the whole string is informativity. Okay, Bob assumes that the note's author, to ensure reliable transmission of information, repeated the data in the message several times. Therefore, he believes that A more plausible decryption of the note would have the smallest possible informativity. Help the spy find the message that represents the decryption of the node and has the minimum possible informativity. So yeah, this seems nice, right? We have n, we have k, both of them can be 50k, and n is length, k is the strips. We have k lines. Okay, n into k is less than or equals to this. That is good for us. So we have n into k less than or equals to 10 power 5. It is guaranteed that this sum doesn't exist. So now we have to determine among these k things. I think we can brute force on D. Okay, we can brute force on D. And then brute force on D is the right way. That's it. I think we'll just go for that. Brute force on D. Now the problem becomes from smallest d, is there a d that's possible, right? And for some d to be possible, what do we want? Is there a character in all multiples of that are of same reminder? Is there a character in all these things? That's what it is, right? So uh, so you will go over all this. Okay, it is, you can do involve n times k, because let's go over all the strings and then let's see if there is some character. Let's go over all the reminders of all the strings and then see if there is some character that is everywhere, and then it's done. If that happens for this reminder, okay, that reminder can be saved, and then we will check for the other reminders, and then we can also find the string. Okay, we have k strings, right? Why are these problems direct? Like, they're not logical. Like, I mean, they are not like tricky, they are like being direct brute force so far. So far C and B both were like direct. AI can solve this very easily, I guess. So now we'll brute force D. Okay, and if we are brute forcing D, what should we do? For each of the reminder we have to do something. Okay, for each of the reminder. So for each of the reminder, we'll try to see if some character exists for everything. Okay, so if some character exists for all the places is what we have to see. So let's maintain for all characters uh, exists of how many times it comes, frequency. Let's make it frequency of 26 equals to 0. I'll try to see how many times each character appears. Okay, for int I equals to 0, I less than ki plus plus, what do we do? Okay, so let's go over all reminders. Okay, for all reminders we have to test this. We have d length string, let's say. We'll give fail flag, and then for this reminder we'll try to see For each character in the case strings, we have to go over all of them too. Okay, let's say we're trying to go over all of them. First, we have to go over all these things independently. Okay, now we have to see index q times d plus r, and for this index, if a character exists somewhere, then we have to keep it I. If s of I of idx equals to exists of minus a equals to 1. Okay, now I will try to update how many times this have existed in frequency. Okay, now if something exists, if something frequency is greater than or equals to n by d, equals to n by d, we are good. For every character, for every reminder, okay, if some character is this, then this reminder is good. Else this reminder is failing. For I equals to 0, I less than 26, I plus plus int OK equals to 0, if frequency of I equals to n by d, OK equals to, this should happen for everything, 1. If not OK, this reminder is failing and then everything will fail. If not failed, I have to just push answer dot pushback of pause. So it's a direct problem, but I took a while unnecessarily. I took 10 minutes. Though in implementations, I have to be careful. My eyes are hurting, haven't slept properly. Fuck is that? Given a table of size n cross m where each cell contains either 0 or 1, the task is to divide it into two parts with a cut that goes from top left corner to the bottom right corner, the cut can only go down or right. Let A be the number of ones in the one part of to the cut and B be the number of ones in the other. Goal is to maximize the value A times B. Means you want almost equal number of ones in both cuts. Okay? Fuck. Why would this happen to me? No, I have to output it outside. No, that's right. I missed D reminder equals to N. This is not worth the wrong submission. I should have been careful. I hope there are no other mistakes. I don't think there are any other mistakes. It should be reminder. It should be divisible. Then everything will work out. Fuck. So we can do O of n into m. Okay. And now for this problem, I think it's brute forcing, and then able to find for all the ways you're able to find minimum number of ones. Both sides will be equal. Is what you want. Wait. Is Okay, is it always possible to split? Okay, because we have too many states, right? If you are brute forcing for all possible value, what all are possible for one cut, there are too many things. But I think, is it always possible to make them almost equal? One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's always possible to make them almost equal. How do we do that? Let's find the cut. First, let's separate some rows and some rows, and then we'll have only one row in between. And in that row, we should be able to half it. So if you keep going like this, like this, like this, like this, like this, like this, there is a point where you will get half, first half, and then you will cut like this. Yeah, and then you will just cut like this. You will come till the half part, and then you will cross it, and then you will cut like this, and then you will cut like this. So it's right, 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 down, right there, and then right, and then all down, and then right. Okay, there is a point where first time you attain floor, not even seal. Okay, number of ones. If number of ones is zero, if there are no ones at all, then what do we do? It's always number of ones. Okay, this is also a bit direct problem. Why are all problems direct in this contest? Are they testing implementation skills? And am I being too slow? So answer is this. First we find dot. If answer equals to 0, let's do all down and all right. I think empty cut should be allowed. Now we'll go for, let's do it row wise. We'll do down, down, right down. Okay. Should you cross here? We're outputting answer already, and we are currently here. Okay. We're trying to decide should we cross this or not. We may cross in between or we may not cross. Okay. If curry equals to tot by 2, crossed equals to 1, and then we'll output down, let's say. Okay. Cur plus equals to a of I of j. So I'm seeing if the current becomes half, I will go down once right now. If that doesn't happen, we'll go down at the end. Right. If not crossed, and we keep going right. Each time we're deciding to cross this or not. Okay. I think I'll check before itself. No, 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 no. What am I doing? The solution is just so simple. You come like this, you'll cross here once, and then it's done. You will find first time where it have happened, and then it's done. Wait a minute. Found. Let me keep it outside. So you came here. There is a time where you will first time you will get that many, right? We are going for that, and you have gotten first time you have gotten first time you have gotten. Now you can output the answer itself. Like you need not do all this. Now you can output the answer itself. Okay, you gotten first time you gotten a curve that is equals to half of this. So now what you have to do? You have to come till here and then come till here and then cross this, go right and then come down. That's it. You have to come till here. Wait a minute. You have to see if come from that side in each column, then you can do that. Okay, now you're coming, now you can come down, right? And then it's done. So you have j things here. You have to come down I times first, okay? And then you have to go right. uh, if, if j equals to m minus 1, you have to go right n minus 1 times. Okay, so you have to go right. If j equals to m minus 2, you have to go right n minus 2 times. And then you have to return the remaining downs. You have to do one down and then you have to do the remaining downs. Remaining rights and then we'll do remaining downs. I plus 1 x less than n x plus plus. I think it's right. Down, right, down. Also, this is direct problem, like, but I'm taking time somehow. Are all problems direct in this? I think many might have solved many problems. Is it because I didn't written here? Why am I making wrong answers like this? What the fuck? Is this an error now? I don't think that can be an error. Fuck, that's an error. Stupid problem. Let's try to read E and F1. Try reading F1 and F2 for fun. Okay. The difference between the versions is in this version k less than or equals to 4. You can only hack if you solve both the versions. Okay. Given a tree consisting of n vertices, each vertex has a non-negative integer a written on it. You're also given k distinct non-negative integers b1, b2 on bk. We will call a set of edges beautiful if after removing these edges from the tree splits into connected components where in each component the bitwise XOR of all numbers A, B in that connected component belongs to the set B. The number of beautiful sets of edges in the tree modulo M. Maybe it looks like a nice counting problem, right? So let's try to simplify what it means to be beautiful and then let's try to uh, what it means to be beautiful. I mean, I'm thinking how can we compliment someone with that? What it means to be beautiful. Where in each component the bitwise XOR of the numbers should belong to that set. Here k is small, but in difficult problems k can be an easy problem. Definitely solving difficult problem. K is even in the difficult problem k is just 10. Okay, maybe 2 power 10 times 1e5 is possible. Oh, it's 1 second. Okay, but k equals to 10 shows it's like 2 power 10. It's like bit mask. Okay, what all sorts are possible? So for each subtree, if you know what all XORs are possible, if you're removing it, if you're not removing it, two things, right? If you're not removing it, see, uh, if you are removing it or not removing it, that subtree is split into things that can be. So what we can say is that subtree can be split into things that can be. I think all problems are being direct in this. See, for a subtree, define, you will hold this one and then you will divide everything into that. What's the XOR of remaining things that can be split into different things? Okay. What I mean is each possible splitting will have XOR. If you ignore the XOR of root component, each of them will have such that see we into different things such that root can be anything but others must be in set. Okay, this is the condition. So because others are in the set, their XORs can only be 2 power 10, right? 2 power k. So this will be of 2 power k values. Okay, if that is having 2 power k values, and what are these 2 power k values? Subsets of B. These are the 2 power k values. The remaining things. And you will find count of splittings for all these things. Okay, and what do you want finally? You want finally values for which even the root will be in B, which is nothing but total times this value. So that can be done. So if you can find this, you can solve the problem. Now try to think of recursively. You have this. Okay, you have different values here, different values here, different values here, different values here, different values here. If you're attaching this, if you're not attaching this, uh, let's see how that affects XOR of before things. Okay, if you're not attaching this, you have to find different values in which this can also be in B, and we also define something else. This can be in B, also root can be in B, and if root can be in B, the total XOR's value will be number of splittings. The total XOR value is fixed already because total XOR is nothing but just the total XOR, right? Okay, so if this is divided, then the XOR contribution of this is fixed. If that is not divided, you have multiple values of XOR contribution. So that is just direct product. So you can solve the problem in 2 power k per edge. And then you have this thing. So initially you have one thing where XOR 0 itself is possible. Now you are considering this subtree. Not adding that subtree is one way. Adding that subtree is one way. If you're not adding that subtree, uh, if you're not adding that subtree, also this is an implementation problem. But yeah, if you're not adding that subtree, what are the different possible values? XOR is fixed. So number of ways this can be split, and that many number of ways. I think we cannot do this in 2 power k. We have to we have to make it like We should know the XOR of the current thing. Only then we can proceed. Let's say you have initial XOR of everything is 10000. Nothing is added. Nothing is added. You have only one thing. So XOR of remaining things is zero. Only this vertex. This is possible. Now you are trying to add something. So both are having equal scores. Okay, now we are trying to add something. And with this, if you are not adding this at all, whatever the so far tree is having number of ways, if you are not adding this at all, how will that transform is their XOR will become uh, yeah, everything will become this total XOR that will be added. Okay, that's one transition. Let's say this is DP. You have DP of so far possibilities. Okay, now temp should be added. B of V, which is nothing but B of total, let's say B of U times XOR I plus equals to dp of I, because this be the XOR of the remaining things so far. Now you have I, this contribution will be b of I. So these are the possible things where if you are not adding it, if you are adding it, this is not dp, this is uh, let's call them good. Now if you are adding it, it doesn't matter about good. Now temp of, now for mask, for j, I hope these values are unique. Yeah, these values are unique. But if the values are unique, does that guarantee that we'll just find what are all possible different values that they can form? Okay, they have this each different values that are possible. Okay, so for j, for different values here, whatever the count is, and if that splitting is there, that count times or p of u plus dp of u, the remaining things being dp of u, this being j. Now dp of u, XOR I, remaining things being I, dp of I. This is good of u, sorry. And dp is of length L. Let that be 2 power 4, 16, right? We have four different values at max. How many different XOR subsets are possible is 16. We also have DP. Now we just do DFS. Okay. While doing DFS, okay, before that we set L. We're trying to find all possible subsets. Okay, now we have L, we have all the values that we know. Now we will write DP. And then dp of v of 0 equals to 1. Initially, only one set of size 0 is possible, right? We'll also have one vector int temp l comma 0. For int u aj of v, if u equals to p continue, let's say, okay, now if u not equals to p, what should we do? We have this set and we have our formulas ready very well. right? For each different values, if you're not adding that, we have good of u. First, we have to do DFS of u. This will form good and the other thing, okay? Now, let me add, let's, first let's try to make temp as 0. After making temp as 0, we will try to store in temp, right? Now, if you're not taking this at all, means it is good. If you're dividing that, this is good. And if it is good, you know what its XOR is, right? It's XOR is just total XOR. I'll just make B in the beginning. B is just below things XOR, subtrees XOR. So now number of ways this can be split. For all that, this will be added, right? So for here, I is vals, okay? Temp of B of U XOR val plus equals to dp of val. Temp of B of U XOR val reminder equals to mod. What is mod 199 plus 7? What is this dp of U? So this is one possible things. What are other possible things? This is not being split. This is being attached. If that is being attached, it can this below things can take multiple different values. Right? What are the different values they can take? That is already there in. Oh, this is good. Good of you. Good of view times dp of I. Okay, now that is done. Now we have to deal with the other values. This is going to be L square, I guess. This is L square. Val of U equals to vals of J, let's say. Val of B equals to so far whatever is there. Vals of I, let's say. So now this thing has been, for this the XOR has been, we're brute forcing this XOR to be val V, okay? This XOR to be value, and they both are connected. And you know number of ways in which this XOR is value, that is dp of U of J. number of ways, that is dp of v of that, and you will try to add this to temp of, oh, you need inverse index of values. Let's maintain a map for that. Map int vals. Let's clear in vals dot clear off, and then let's push these things in vals of b equals to l. Int pos equals to in vals of b of u xor val. So that position should be updated, and dp is not I, this is I. Instead I could have used dp map, but dp map is bad, right? Wait a minute, why is this wrong? Before it was b of u xor val, now it is val u xor val v. Let's put the position +1, okay, and then let's do -1. If pos not equals to -1 means if it exists, pos equals to -1, continue. Now what should we do? Temp of pos plus equals to, this is dp of I or dp of j, dp of v of I times dp of v of j, u of j. Reminder m, temp pos reminder equals to m. So this is done. Now what should we do? Everything is done. Now uh, we should just replace dp with temp, right? Now we have to deal with good. Hmm, instead of going over k, let's try to see what are all each possible down values. Okay, among this only few are good. We have to add them for each possible down values. How do we do that? Int root val equals to p of v xor vals of I. Int present equals to 0 for I equals j equals to 0, j less than k, j plus plus. If root val equals to b of j, means it is one possible thing, then present equals to 1. If present, then what should we do? Yeah, this is being nice for this kind of below structure. So we have to add good of v plus equals to dp of v of I. Good of v remainder equals to m. It's a simple problem, like it's not too difficult of a problem. It just has steps. Okay, I'll try to investigate this one. Oh, why the answer is changing? Answer is still changing. I have to take values input. I have to take b input. Okay, now let's think about the problem again. Here, here it should not be one. We have the graph. This should be done quick. We have the graph 1, 2, 2, 3, 3, 4. Each of them having values 1, 1, 1, 1. Okay. How many ways can you split them so that everything is odd? I think you can split everything. That is one way. You can split at if you're splitting this or not splitting this, let's count. If you're splitting this, uh, then you have these three things which can be kept like that, or they can be divided into individuals. That is two ways. Plus, if you're not splitting this, they have to be together, and if they are together, also this should be together. That is one way. So answer is three, not one. So what might be going wrong? For this, dp of 0 should be 1, other thing should be 0, right? Because we don't have any things. And then for this, dp of keeping this, you can cut this or you may not cut that. If you are not cutting it, dp of 0 equals to 1. If you are cutting it, dp of 1 equals to 1. And good equals to 1. Here good equals to 1 because if you are not cutting it, only this is good. This is not good because if the total will not be matching, right? And dp of 2, where would what would we be doing wrong? I don't think we are doing anything wrong. Whereas we used inverse here and then we did minus 1 immediately, we have. Now let's check clearly. This should be correct. Let's just check. Let's just go on and let's compute for this one too. For 2, if you are attaching this, if you are not attaching this, it's about number of good things, right? So dp of 0 equals to number of good things 1, if you are not attaching this. If you are attaching this, even now you can have. If you're attaching this, even now you can have dp of 0 to be dp of 0 of this. So for 0 and this being 0, that would be plus 1, and dp of 1 would be, here you don't have any choices. Here it's always 0. You're attaching this. You may divide this, then you have that to be 1. And good is, I think good is just dp of 0, which is 2. Now dp of 0 is again, now dp of 1 can be, if that is divided, then dp of 1 is good, and dp of 0 is, if that is attached. Okay, when that is attached, you can have again one more dp of 1, which would be this cut. Good equals to 3 here. So let me just check these values now by printing them. We have 1 1, we have, so this is what? 4 3 2 1. So for 4 we should have 1 1 1. So for 4 we should have 1 0 1. This is being wrong. 4 itself is being bad somehow. No, this cannot be wrong, right? How is this going wrong? But it never enters here. This should be outside. This should be inside. Okay, we have 1 1 1. We have 2 1 2. This should not be DP of 1. What does that? Something has been cut out. Okay, which is only possible when these two are attached. DP of 0 is 1, DP of 1 is 1, so it should be just 1 plus 1. It should only be coming when this is attached. If this is cut out, then it's not possible. If this is attached, where that is in the code, here it is attached. So now we are trying to say this being 0, this being 1. One of them is 1, the other one is. So here we are adding 1. When it is attached, can it become 1? Think about that. When it is attached, oh, even then it can become 1, but it can never be good. What am I doing? When it is attached, it can be 1. Yeah, it should be 1. When it is not attached, you have dp of the b of u is 0. Oh, this should be v because we are brute forcing vals of the previous one and then we are taking good. That's a bug. I hope that's the only bug. Yeah, that's likely the only bug. costed quite good amount of time. I should have just been careful. There's no other way than being careful in coding. You have to be careful. That's the only way to reduce implementation mistakes. You have to be careful. You cannot be like half asleep like me. Now I have only 35 minutes to solve the other problem. Fuck. Yes, please. Let this shit pass everything and then I have to solve this problem. I'll try to judge quickly how difficult can this one be, okay? Uh, After a heavy training session, Michelango and Raphael decided, fuck, wait, can n into 16 won't work? Maybe this is being too much. This thing. How can you reduce this vals here? We have huge memory possible. I think this is like a bottleneck. Maybe unordered set is good. Oh, was this the issue? I hope hash is quick enough. This is surely a stupid problem if it passes. Looks like it's passing. Let me try E, please. Uh, Michelango and Raphael decided to order pizza today on the occasion. Pizza! Is that a code word for children? Today, on the occasion of the day, the pizzeria is preparing rectangular pizzas made on N rows and M columns of slices. Each slice has its unique own recipe and flavor. Michelango was the first to open the box and roughly estimated the pleasure of each slice. And roughly estimated the pleasure of each slice. The pleasure from the slice located in the ith and jth column is Aij. It is guaranteed that at least one slice that Michelango liked, meaning that among Aij there is at least one non-negative number. So there can be negative numbers. So there is at least one non-negative number. Turtle agreed to that Michelango would eat first. According to an ancient tradition, he must choose a route from top left corner to the bottom right corner and eat all the slices on that route. In one step, he can move either to the adjacent slice in the right or adjacent slice below. Michelango aims to maximize the total pleasure from the eaten slices. However, Raphael decided to use sauce. Before Michelangelo chooses a route, Rachel decides to choose exactly one slice of pizza and apply his signature sauce to it. But due to specifics of this sauce, the pleasure from that slice changes to its opposite. If it was after that, knowing Rachel's choice, Michelango will choose the optimal route for himself. Becomes curious about the minimum possible Michelango could achieve. Help him calculate this number. So yeah, we have to think about this problem. Like he can reverse it. Okay, one thing is very clear what to be done. So flip one thing. Is that a must thing? N is one and M is one. N can be one and M can be one. Then is that a must thing? One slice of pizza and applies his signature sauce. So if it is one comma one, he will definitely flip that. He must definitely flip that. Most of them will have something common. I'll go to washroom and come back. So I think we can try to find one optimal path for sure. Okay, there's one optimal path, and he must choose one of these. If he doesn't, wait. If he doesn't choose one of these, okay. there's an optimal path, right? So if he doesn't choose one of these, he can, if he doesn't choose one of these, he can never make better, is what I want to prove. uh, if he's not choosing one of these, then just flip the positive one to negative. If you're flipping the positive one to negative, there is now no better thing. There's no better thing, right? Let's say we have optimal. If he's not choosing optimal, let's say that he will try to flip that. So it's definitely never better than the optimal value. Okay, if he's not flipping optimal, we have optimal possible. And why would he go and make something negative as positive? That's definitely bad, right? He will make positive as negative. Because making a negative as positive doesn't seem good at all. Instead, you could have made this positive as negative. Okay, that clears things. If it's only going to get worse, optimal is the best. So he must choose optimal. Okay, leave that. This will help that. He must choose optimal. I should not overthink here. Can we brute force this? Now, we have an optimal path, and he is definitely choosing one of these things. Okay, if you have an optimal path, this value has been flipped, let's say. This value has been flipped. Okay, now think of these things. Oh, can I implement it in time? It's not a difficult problem. Let's just say we are brute forcing optimal path. Okay, let's say this is our optimal path, and we are trying to brute force this value being flipped. Okay, so if this value is being flipped, what is the optimal? If you never encounter this value, if you are encountering this value, you know the answer. Come till here. So let's just focus on this row. You may enter this row sometime and then you may leave this row somewhere, right? If you enter here and leave here, let's say you're where you will leave this row. Let's try to fix that. Let's say you're leaving this row here, then that's good. Or if you're entering this row here, also that's good. If you're entering it before that and leaving it before that, maximum values among all possible these things, can they be computed? Let's say you're entering here, let's say you're leaving here. Okay, coming till here, all possible ways, and then leaving from here would be all possible ways. So that is done. Like if you know max from this cell to this corner, this cell to this corner, this can be computed. And entering here also can be computed by, if you know for this one from here to here. For this one, from here to here, that can be computed. So not involving this, we have computed all the things. Now we have to find involving this, what are all the best paths. Okay, how do you find involving this all the best possible best paths? Involving this one. So if you are involving this means you are entering before this and leaving after this. So you have some possible values for this. Okay, let's say you're entering somewhere here. You have this dp value, and then you have this dp value. Now I think this can be done using this, but can I implement it in time? I'm not sure. I don't think I can. Wait, you have O of n plus some things, right? Can you brute force more because it's just O of n plus m? Can you fix one of these where you start? Okay, if you fix one of that, because it's per that, you're fixing that. Okay, let's say you won't fix this, you won't fix this, but then you will try to compute this starting thing in terms of dp till here plus sum before this minus sum before this, because total sum is fixed, right? And then dp till here minus sum before that. You want maximum value here and maximum value here, dp till here minus that. That's it. And then you have your, with respect based on total sum, you will have your, often you can get dp till here minus this previous sum. Often you can get dp till here minus this previous sum, whatever the maximum is, till here and till here, starting and ending, and then it's done. What about the remaining things that starts here? So it is done, but can I implement it within time? I'm not sure. It's difficult. Let's just say you have uh, coming till here optimal ways from here and coming till here optimal ways from here. Now we have three things, okay? By flipping one among this, okay, for this row you have entering this, what are the optimal ways you have? Entering this, leaving this, you have the optimal ways. Now by flipping at max 1 in this, what is the optimal, what is the answer you have to find? If that problem can be done, the answer is done. You need not even find optimal path. Keep optimal path aside. You can brute force this shit itself. Given this thing, let's say you're fixing this. Let's say you're flipping this. You're definitely crossing this. Okay, this has been flipped. Without crossing this, you can do it in often. Enter, leave, enter, leave. With crossing this, you have to choose one thing here and the other thing here. And here this sum. I think this can be done. I have to just find DPs from this corner, DPs from this corner to each cell, and then I have to pass one vector entering vector, one vector leaving vector. And then that will be of another problem. Let's try to do this in 9 minutes. I don't think I can, but let me try. Entering vector, leaving vector, and then the other problem is okay, given an entering vector and leaving vector, you have this thing. By flipping this, what's the optimal value? Leave before that or leave before that? So let's try to find an entering vector and a leaving vector first. So we're able to brute force each cell itself. And then I can just take this itself. Let's say DP start and DP end. DP start is optimal path starting from there, let's say, okay? DP of I of 0 equals to for each row we are trying to find DPs, okay? Let's just keep row 0 already. DPS of 0 0 equals to A of 0 0. So DPS is done. Let me do DPE. I can do it in time. Okay, without touching this, how would you do without touching that? DP till there, maximum of DP till there plus DP after that, right? You want prefix minimums of these things, prefix maximums of those things, and then including this one, you can try to do DP of starting from here and then going from here while you change the value to uh, sign changing the value. That's a simpler one. I'm unlucky for sure. It's like living before this. Okay. Next thing is there, you can leave before that, and then it will be dps of I of j plus dpe of I plus 1 of j. That's it. Now you do prefix maximum. Now let's just do prefix maximum. Okay, now let's think about suffix. You have to enter that first and then you have to do this. I minus 1 greater than or equals to 0, else you cannot enter there. Why am I so unlucky? Should I have been a bit quicker, little bit quicker? I'll get negative rating in this. So now we'll brute force flipping this one, okay? So we have before crossing that, we have after crossing that. Now crossing using this one. This is likely the answer. Why was I not able to code this in 10 minutes? I thought it is much more complex. I thought it is much more complex. But using that is just this one. Using that is just this one. Fuck. I unnecessarily overcomplicated this shit. I unnecessarily overcomplicated like coming till here and then going till here. You can just come till here and then leave from there. It's a simpler problem than what I have imagined it to be, right?